So welcome to Everyday Mathematics. Today we are on the MIT Integration B Qualifying Exams 2026 that was held today, the 20th of January 2026. And we're looking at the first 10 problems of that qualifying exam. Problem number 1 as shown here, problem number 2, problem number 3, problem number 4, problem number 5, problem number 6, problem number 7, problem number 8, problem number 9, problem number 10. So these are pretty easy problems. We'll just go through them and try to see how we may be able to solve them. So let's jump into the solution without much ado. So problem number 1, which happens to be a definite integral from x goes to negative pi to x goes to pi of sine of x to the power 2025 times cosine of x to the power 2026. So let's see how we may be able to solve this. There are two ways to go about solving this problem. The first would be, so the short version of the solution, we have negative pi to pi integration of sine to the power 2025 cosine 2026 of x. So we can see here is that we do have an odd function here, and that's symmetrical about, not symmetrical, but the next one, let's not dwell so much on that. And this is an even function. And an odd and even function multiplied together, we get an odd function. So which means that if you probably have a if this is 0, this is x, and this is y, you'd have something like this, right? And this area here would cancel with that. So in other words, this is equal to 0. So intuitively, that is how you may be able to solve that problem. Now we're going to try and solve it in a more detailed fashion without wasting much time. Let's go and try and do that. So if this be our problem, right? Yeah. And this can also be expressed as x cos x and this two here could be seen as okay. We can pull the constant out. Now, using integration by parts, such that if you have an integral of a product of function v and the derivative of function u, when you integrate that, you have a product of function u and v minus the product of function u and the derivative of function v. So using that, which is, if you have interest, you can go and look at this topic, integration by parts. Okay, so we take sine x to the power 2026 as being v, and cosine of 2025, cosine of x to the power 2025 x as being, this is this, and then cosine of x to the power 2025x is v. We apologize for that confusion. So v is cosine of x to the power 2025, and then u is sine of x to the power 2026. Okay, so our problem is 1 over 2026 dx of sine to the power 2026 of x cosine to the power 2025 of x. So uv will happen to be that limits minus u, the derivative of v. So as we can see here, this goes to 0 at both the upper and the lower limits. So essentially this goes to 0, and we are left with negative. So let's put these limits here. Okay, differentiating that becomes, let's maybe rewrite that. So we have negative 1 over 2026 so this becomes negative, so we have 2025 over 2026 and 6, we have cosine of 2024 out of the power 2024, and then we have sine of x. So this is sine of 2027 to the power 2027x cosine of 2024x. Okay, so since our problem has gotten us to 2025 over 2026, sine of 2027 x cosine 2024. So without really belaboring the point, if our initial problem sine of to the power 2025 of x cosine 2026 of x was able to bring us to this, then we see that 2025 jumped 2 times to that. 2026 jumped 2 times to the lower value like that. So in other words, this can be okay. So this can be 2024 over 2028. Sine 2029 of x, cosine of 2020 2 x. And so this can go on all the way until we have 2025 factorial, and then we have 2026, 2028, 2026, 2020, 2030, all the way until we come to a point where we have sine this x, and we have 2025 plus twice times 2025 dx. And since this is an odd function, this entire enterprise will go to 0. So it goes to 0. And so the integral from x equals negative pi to pi of sine to the power 2025 of x times cosine to the power 2026 of x is equal to 0. So that's how one may be able to try and solve that. It's a little bit intricate if you try to solve it, but if you look at just the behavior of the function, it's easy to jump straight into the answer. So without much ado, let's move on to problem number 2. Number 2, which is indefinite integral of e to the power 2026 e to the power x times plus x. This you could easily express it as e to the power 2026 e to the x times e to the x. And we can now say let u be e to the x such that du dx is equals to e to the power x. And so you can substitute for e to the x dx with du. So this already here is our ex dx. So the problem becomes e to the power 2026 u here du. And this becomes 1 over 2026 e to the power 2026 u plus the integration constant. And since u is equal to this guy here, we can now say that our problem, the integral of e to the power 2026 e to the power x plus x, the answer is 1 over 2026 e to the power 2026 e to the power x plus the integration constant. And this, ladies and gentlemen, is the answer. Very easy and straight to the point. So problem number 3, which is kind of tricky but straightforward, which happens to be the definite integral from x equals to 0 to x equals 2026 of the fractional part of the floor of x over 3, and this is how we may be able to solve it. First of all, we've got to define what is a fractional part of a function, for example, of x. Fractional part of x is equals to x minus the floor function of x. So it's just fractional part over any integer. And then one may ask, what is the floor function of x? The floor function of x is equals to integer k if x is less than k plus 1, integer k plus 1, and greater or equal to k. So it's that integer value lower than a real number of k. Now, for example, the floor of value negative 2.1 is the negative 3. The floor of positive 2.1 is positive 2. That integer lower than the real number we're looking at. Anyway, so into our problem here, we get to realize that this fractional part here, it lies between 0 and 1. It's never 1, but it's that fractional part between 0 and 1. So, and then what we'll see here is it becomes, because now we can discretize x between 0 and 1, this becomes 0. X between 1 and 2, this becomes 1. And so we can say, okay, we can discretize the integral from k equals to 0 to k equals to 2025. And then we're integrating from k to k plus 1 of the fractional part of k over 3 dx. Anyway, right? I think that's what. And you can swap the summation and the integral sign pretty readily. Anyway, so this becomes, since this is a constant here, 0, 2025, and we have k over 3 which is equals to k equals to 0 of the fractional part of k over 3. Anyway, so this becomes, when k equals to 0, we have 0 over 3. When k equals to 1, we have 1 over 3. When k equals to 2, we have 2 over, the fractional part becomes 3 and becomes 2 over 3. And then as soon as k equals to 3, the fractional part is going to be 0 over 3. Not 0 over 3 rather, apologies. But it's going to be 3 over 3 fractional part, which is, yeah, 0 over 3 is correct, or 0, plus when when k equals to 4, we have the fractional part being 1 over 3, because we have 3 over 3 plus 1 over 3. And then when k equals to 5, we have 2 over 3. And we continue on and on and on. And okay, so this is and so we go until we have 20 0 over 3 plus 1 over 3 plus 2 over 3. Okay, so this part here, when you add together, is 1. We have 1. We have 1. And so since we are beginning with values 0 up to 2025, we have these grouped in clusters of 3, but the total values here are 2026. Okay, so in other words, this here is equals to 2026 divided by 3. Actually, let's okay, so this becomes 1, 6, 7, 15, 5. So this is 675 as the answer. Okay, so that is it. It's not as complicated as it looked. Anyway, let's go to the next solution. Problem number 4 happens to be the definite integral from x equals -1 to x equals +1 of the absolute value of x plus absolute value of x plus the absolute value of x, and so on and so on and so on. So this is a very interesting problem, and how I would try and solve it is I'll just draw it like that, and we have -1 here and +1. And we see that in the negative domain, any negative x value, this part becomes 0, because if we have a negative x, and so this part becomes 0, and we see that this part also becomes 0 and 0. So you're going to have this entire duration being equal to 0. And then since we have this repeating themselves for 2026 time, we see that when x is positive, this add up to 2026. And so our integral becomes the area of this triangle, where the height is 2026 and the base is of length 1. So in other words, the integral from x equals to -1 to +1 of the absolute value of x plus absolute value of x plus absolute value of x plus the absolute value of x, close bracket, is equal to a half times the length of the base, which is 1, times the height, which is 26, which is 1013. So the answer is that. So problem number 5 is the indefinite integral of 1 over square root of x plus 1 minus square root of x minus 1. So this is easy. we have square root of x plus 1 minus square root of x minus 1 in the denominator. How you'd solve this is you open bracket, multiply this by denominator by the square root of x plus 1 plus square root of x minus 1, and also the numerator you do the same. Yeah, and since we have a difference of two squares in the denominator, this is the same as x plus 1 plus square root of x minus 1. So it's the same as this squared minus this squared. So we have x plus 1 minus x minus 1. And we see this x and x go. 1 minus minus 1 is 2. So we have half of right. And this is the same as a half x plus 1, a half x minus 1. Okay, so that's straightforward. Since we have integral of x plus 1 to the power half plus x minus 1. This is the same as a half, 2 over 3, x plus 1, 3 over 2, plus x minus 1 times 2 over 3, 3 over 2, plus integration constant. And we see that cancel. So we have a third, x plus 1, 3 over 2, plus x minus 1, 3 over 2, bracket, C, such that our initial problem is we don't need this. Plus the integration constant. And that, ladies and gentlemen, is the answer. Problem number 6 happens to be the indefinite integral of the square root of 1 plus cos of x. And here we could use the identity cos of x is equivalent to twice cos squared of x over 2 minus 1. Right? And that means our integral now becomes the integral of the square root of 1 plus twice cos squared x over 2 minus 1, such that this and that cancel, and we do now have square root of 2, the integral of cos of x over 2 dx. And this just becomes twice square root of 2 sinh x over 2 plus the integration constant. And that is the answer, ladies and gentlemen. So problem number 7 is indefinite integral of 2 to the power natural logarithm of x over x squared. So what is twice 2 to the power log of x? Let's take this to be y, such that log natural logarithm of 2 log of x is equals to natural logarithm of y, meaning that log of x log of 2 is equals to log of y, which means that log of 2, not log of 2, let's means that log of x to the power log of 2 is equals to log of y. So in other words, y is equals to x to the power log of 2. Okay, so integral becomes x to the power log of 2 over x squared, which means this is the same as x to the power log of 2 minus 2. And so since our problem now has become it means that this is the same as x to the power log of add 1 to the power, so it becomes that, and then the denominator becomes that. So not that, rather, sorry. Plus the integration constant. So the integral of, in other words, 2 to the power log of x over x squared is equals to x to the power log of 2 minus 1 over log of 2 minus 1 plus the integration constant. And that is the answer, ladies and gentlemen. So problem number 8, which is a definite integral from x equals 0 to x equals to half of the summation from n equals to 2 to x equals to x tend to infinity, n equals to infinity, 10 to infinity of x to the power n. So here I think we can use geometric progression. So if you have a scenario where you have r to the n, where n straddles from 0 to infinity, this is the same as 1. And this happens when r absolute is less than 1. Okay? So this integral becomes something like that. Since x is less than, the absolute value of x is less than 1, minus x, so minus 1 minus x. So this becomes 0 to a half of 1 over 1 minus x minus 1 plus x, which is equals to negative log of 1 minus x minus x plus x squared over 2, 0 to a half. So this becomes minus log of half minus a half plus a quarter over 2 minus 0. And this becomes a half plus 1 over 8. 8, 4 plus 1 is 5 over 8. So we've come to negative log a half minus 5 over 8. And this can be re-expressed as positive log of 2 minus 5 over 8. Therefore, the integral from 0 to a half of the summation from n equals to 2 to n equals to infinity of x of n is equals to log of 2 minus 5 over 8. And that is the answer, ladies and gentlemen. Problem number 9 happens to be indefinite integral of x squared times sine of x. So we can re-express this in this formalism. Sine of x is the same as the derivative of negative cosine of x. And then we can use integration by parts, where if you have an integral of the product of a function v and the derivative of function u, that's the same as uv minus the integral of a function u times the derivative of function v. Now, as shown here, this happens to be our u and this happens to be our v. So this means that our problem is the same as uv, which is negative x squared cosine of x. And then we have minus negative cosine of x times the derivative of that, which is 2 cosine of x. So this and that interact. We have negative sine x cosine of x plus, actually twice cosine of x, like that. We can further re-express this plus twice x derivative of sine of x. And so if we have negative cosine of x, negative x squared cosine of x plus twice x, the derivative of, we have expressed the cosine x under that as this. And so using integration by parts again, we have x minus, and so we have sine of x, because the derivative of x is 1, and that is what we have. And this is the same as x squared cosine of x plus 2x sine of x plus twice cosine of x plus c. And therefore we can consolidate this. So we have 1 minus, actually 2 minus x squared cosine of x plus 2x sine of x plus c. Therefore, the integral of x squared sine of x is equals to 2 minus x squared cosine of x plus 2x sine of x plus the integration constant. And that, ladies and gentlemen, is our answer. So problem number 10, indefinite integral of x minus 1 squared over 2 to the power 2 times e to the power x plus x squared plus 1. I think we can express this as, we can expand the numerator, so we have x squared minus 2x plus 1 over 2ex plus x squared, like that. And this is the same as 1 minus 2ex plus 2x over x squared plus 1 plus 2ex. Okay. And so this becomes 1 minus the derivative of x squared plus 1 plus 2ex over x squared plus 1 plus 2. And so since our problem now has become derivative of x squared plus 1 plus 2ex over x squared plus 1 plus 2e. And we know that if you have a derivative of a function of x over fx integrated, that's the same as logarithm of fx plus c. So integral becomes x minus natural logarithm of x squared plus 1 plus 2e to the x plus c. And therefore, our integral, indefinite integral of x minus 1 squared over 2e to the x plus x squared plus 1 is equals to x minus natural logarithm of, let's say, plus the integration constant. And that, ladies and gentlemen, is our solution.